Now that we've talked a little bit about our LAN design and our form factors, let's talk a little bit more about switching as a general concept. A switch makes a decision based on the ingress or destination and the destination point, meaning where it comes in and where it goes out. The LAN switch keeps a table that it uses to determine how to forward traffic through the switch. So it learns this information as traffic is going on. The Cisco LAN switches forward Ethernet frames based on the destination MAC address. And remember, each device has a MAC address. Dynamically populating a switch MAC address table. Like I said, a switch must first learn which devices exist on each port before it can transmit a frame. And it builds this table called the MAC address or contact addressable memory table. The mapping device port is stored in the CAM table. And the CAM is a special type of memory used in high-speed searching applications. The information in the MAC address table is used to send frames. And then when a switch receives incoming frames with a MAC address that is not in the CAM table, it's going to flood all ports but the one that it received it from to find out where it's going. So then it's going to learn that particular address as well. So with our switch forwarding methods, we either have store and forward or we have cut through. The store and forward switch receives the entire frame and computes the CRC. And if the CRC is valid, the switch looks up the destination address, which determines the outgoing interface, and then the frame is then forwarded out the correct port. With our cut through, the switch forwards the frame before it is entirely received, and at a minimum, the destination address of the frame must be read before it can forward it on from there. With store and forward switching, it allows the switch to check for errors and perform automatic buffering. And it is a slower forwarding process because it's looking at the entire it's looking at everything in that header. So it's looking at everything. So it takes a little bit longer to read all parts of it before it sends it on. With cut through, it allows the switch to start forwarding in about 10 microseconds. There's no error checking, there's no automatic buffering, and the frames can begin to be forwarded as soon as the destination MAC is received. Next, we have our collision domains, and that is a segment where devices must compete to communicate. All ports of a hub belong to the same collision domain, and every port of a switch is a collision domain on its own. And a switch breaks the segment into smaller collision domains, which eases device competition. In the ebook, it gives a great example of how this frame forwarding takes place. Here it's going to show you how if switch port 1 has a destination address of EA, then it goes through its table. It knows that EA is on port 4. So let's watch this work. So that's a good example of how our frames are moved throughout the switch. Now let's look at how the address table is populated. Here we're going from PC1, it's going to send a frame out to this switch, and it's going to come in on port 1 because that's how they're connected. Once the switch receives this information, it knows that the port 1 belongs to the MAC address of PC1. However, port 2 and port 3 are empty at this time. It hasn't learned that information. So it sends the frame out both ports to try to find where that frame belongs. It belongs to PC3. So it sends the frame back that it received it. And now our MAC table is populated with the MAC address of PC1 and the MAC address of PC3. So once it comes back, now we know anytime information is sent to this particular MAC address, it knows to forward it out of port 3 because it has learned this information. Next, we can look at the information and an example of how the store and forward works. You can go through and play both of these and you will see how it looks at the frame header information. It gets all the bits and pieces out of it that it needs, and remember that store and forward is going to be slower than our other method of cutting through switching. Okay? Because with our cut through, it only grabs that destination information and it goes ahead and sends it from there. Again, with our store and forward switching, we've got error checking that's going on. The switch using the store and forward looks for the error of the incoming frame, and after receiving the entire frame on the ingress port, or the one that's sending it, the switch compares the frame check sequence values in the last field of the datagram against its own frame check sequence to make sure it has everything and there's no errors there. That's another reason why the store and forward is a little bit slower, as it's checking on things. And then we have automatic buffering going on. The ingress port buffering process is used by store and forward switches, and it provides the flexibility to support any mix of Ethernet speeds, because you never know what speed your destination may be working off of. We talked a little bit about collision domains. There's also broadcast domains, and is used to extend of the network where a broadcast frame can be heard. Switches forward broadcast frames to all ports. Therefore, switches do not break broadcast domains. All ports of a switch with its default configuration, keep that in mind, belong to the same broadcast domain. If two or more switches are connected, broadcasts will be forwarded to all ports of all switches except for the port that originally received the broadcast. It does remember where it was received. We can alleviate some network congestion by using the switches, and they help by facilitating the segmentation of a LAN into separate collision domains. We provide full duplex communication between devices, taking advantage of their high port density, because a switch can have many ports on it. We have buffering large frames. We're employing high-speed ports. We can take advantage of their fast internal switching process and having a low per port cost. So we do need to keep all of this in while we're thinking about things and understanding how we're working. So we need to keep this in mind.